We're happy to hear from Dave Weixelman. He has been an amateur astronomer since the 7th grade when he built an 8-inch reflector, grinding his own mirror at that young age. He has been a deep sky nightscape imager for many years, and he'll be taking us on a tour of the Great Rift in the summer Milky Way. So let's welcome Dave.
The dust clouds of the Great Rift. Thank you all for coming. We're going to talk about dust clouds in the summer Milky Way, and we're going to talk about 5 prominent dust clouds that are part of the Great Rift, that compose the Great Rift, and the locations of the dust clouds in each of the galactic arms, the Orion spur, our galactic arm, and a little bit about the structure of those dust clouds and what influences the shape. On the left, you can see a photo taken by famous photographer Tony Hallis, who photographed the summer Milky Way at the Stellar View Star Party last summer. So that's what the Milky Way looked like from likely California at about midnight in early July. And you can see that in the bottom there, Sagittarius is down here. This is Jupiter, by the way. All the way up to Cygnus the Swan right up in here. That's the part of the Milky Way we're going to focus on for the talk. And you'll notice, and many of you are aware of the Great Rift, but for those who aren't, the Milky Way here, the bright part of the Milky Way, the plane of the Milky Way, appears to have a dark lane in it for a considerable distance. That's called the Great Rift, sometimes called the Dark Rift or the Dark River. And so that's what we're going to focus on in this talk. Those are dust clouds in the galactic plane that are blocking stars behind it. And those clouds are very close to us, as we're going to see later in the presentation. So next slide, there we go. So I'm going to use photos to illustrate the Great Rift, but I'm also going to use screenshots from Sky Safari. I like the way that software presents the Milky Way, and you can see the dark rift again here in Sky Safari, all the way from Sagittarius, Scorpius region up to Cygnus the Swan. So there's the dark rift as shown by Sky Safari. And you can see the dark rift very plainly from a dark sky site. You can even see each of the individual clouds that we're going to talk about in a really dark sky. And this kind of simulates the view that we had from Likely last summer. No light pollution at all. Bortle 1 or 2 class, if you're familiar with the Bortle scale. So very dark, no light pollution at all. So why is there a dark rift? Well, the sun is in a flattened spiral galaxy, as you know, and dust is concentrated in the plane of our Milky Way galaxy there. And if you're looking along the plane of the galaxy, which we do when we look at the Milky Way from our vantage point, dust obscures some of the stars in the plane of the Milky Way and hides those stars. So the sky appears dark in those areas. So in simplistic terms, that's the reason for the dark rift in our Milky Way galaxy. This is a photo by Adam Bloch of NGC 1535. And another perspective here, this is a painting from the Harvard Radcliffe Institute, but it shows a painting, a view from above the plane, and there's the sun right here, and we're looking toward the center of the galaxy, but it kind of gives you a perspective of where we are in the galaxy. And we're going to talk about this a little bit later in detail, and when we look closer at where these dust clouds are in the Milky Way. Ignore those red dots for now. That's an interesting story. We'll talk about that near the end. It'll mean a little bit more. But those are dust clouds as measured by the GAIA, ESA GAIA spacecraft. And we'll talk about that a little bit later. Okay, what are dark clouds? The dark cloud, or dark nebula as it's sometimes called, is a type of interstellar cloud that is so dense that it obscures the visible wavelengths of light from objects behind it, such as background stars, which we mentioned. The dark clouds appear so because of sub-micrometer sized particles, dust particles, coated with certain molecules, carbon monoxide, for example, molecular hydrogen, and nitrogen, which has effectively blocked the passage of light at visible wavelengths. So sometimes you'll hear these clouds referred to as molecular clouds and not dust clouds, but I'm going to use the term dust clouds. Okay, and these clouds are spawning grounds of stars and planets, and an understanding of their development is essential to understanding star formation. We're going to get into that a little bit, because in these clouds, if the clouds coalesce dense enough, then you can get star formation, as you know. And so it's an important part of these dust clouds. The form of dark clouds is very irregular. They have no clearly defined outer boundaries, and sometimes take on convoluted serpentine shapes, often in the form of filaments. And we're going to talk about filaments here later on in the talk. Examples are the dark clouds that make up the Great Rift, which of course is the subject for this talk. This is a photo I took from Likely last summer, 28 millimeter lens, and I captured the Milky Way here in Sagittarius up through Aquila the Eagle, and captured part of the dark rift here. Here's Scorpius over here, Antares right here, and the Rho Ophiuchus Nebula right here. This is the Zeta Ophiuchus Nebula, if you're familiar with the constellation Ophiuchus.
Were you out on a desert?
Pinyon pine forest, but again, very dark skies. There's almost no light pollution. Reno is due south here, and so you can see you're far enough away that you really aren't seeing the light dome of Reno, which is pretty prevalent across Northern Cali. If you're a ways away from Reno, this is very northeast corner of California, up near Likely, California, near the Werner Mountains. Pretty dark there, so a really good place to view the stars. And so there are 5 major dust clouds that make up the Great Rift, and these are researched individually by research papers and so forth. We're going to start with the southernmost one down by the Sagittarius and Scorpius region, called the Dark Horse Nebula. Then there's the Great Aquila Rift here, and then moving up to the Vulpecula Rift here in the constellation Vulpecula. And Cygnus the Swan has the Cygnus Rift right here, and then the northern Coalsack Nebula is the topmost one here. So we're going to go through each one of those and talk a little bit about each one of those. Again, these are visible to the naked eye from a very dark sky site, and easy to photograph with using nightscape photography or other means such as that. But these are visible in a dark sky to the naked. So let's start with the Dark Horse Nebula here. It's located in eastern Ophiuchus, near the borders of Ophiuchus, Sagittarius, and Scorpius, sometimes called the Prancing Horse Nebula. Very close at only 650 light years. And we're going to see in a little bit that's close by Milky Way. Okay, and it's quite large, 10 by 7 degrees. It obscures part of the central bulge of the Milky Way. And so when you look in the direction of the central part of the Milky Way towards the core, that direction is towards Sagittarius here. So this bright sort of yellowish core here is the core of the Milky Way. And the Dark Horse Nebula does, in fact, hide part of the core of the Milky Way. If the Dark Horse wasn't there, this core would be much brighter in the sky. So that's an interesting feature. Yeah. So the Dark Horse Nebula. Here's that same photo I took from Likely with the 28 millimeter lens, and you can see the shape of the Dark Horse a little better here. Here's the head of the horse. Here's the front legs, right? And here's the hind legs. The hind leg is referred to as the Pipe Nebula. That's a famous in Leland's catalog of dark nebulae. It's a famous nebula, and there's a lot of research being done on the Pipe Nebula here. Here's the Rho Ophiuchus complex, if you're familiar with that complex. Again, the Zeta Ophiuchus cloud here, and the Lagoon Nebula right here next to the horse. So basically, if you're in a dark sky and you look between Sagittarius here and Scorpius here, you can see the Prancing Horse Nebula, the Dark Horse Nebula. It's actually quite prominent, very prominent in binoculars.
How long was this for?
I think those were about 1 minute, 20 seconds tracked. So I had a mirrorless camera, Canon RA. It was sensitive to H alpha light, and I took about 1.5 minutes tracked on that. And I took a picture at twilight of the foreground, kept the tripod still and the camera still, and then photographed the night sky there about 2 hours later, and then blended it. So that's how that photograph was made. So here's Tony's picture again that we started out with, and you can see the location of the Prancing Horse or Dark Horse Nebula down here, close to the horizon. And there's the features we talked about with the horse. Again, Jupiter's there, right? Just happened to be in that part of the zodiac at that time. So Dark Horse Nebula. Now, where is the Dark Horse in the Milky Way Galaxy? In order to look at that, let's review the Milky Way Galaxy for a little bit. So we are in a barred spiral galaxy, as many of you know. This is a face-on view. And we're about halfway from the center of the galaxy to the edge of the galaxy. It's about 26,000 light years from the sun to the center of the galaxy, right? We're between the Sagittarius arm of the galaxy, which is right here, and the Perseus arm of the galaxy, which is right here. And between those two arms, sandwiched between those two arms, is the sun, as many of you know, in a smaller arm called the Orion spur, which takes off from the Sagittarius arm and kind of goes like this. Sometimes it's called the Cygnus Orion spur, but we're going to call it the Orion spur for now. And a little bit about distance here, you can see that the Pleiades are very close to us, only 400 light years. And if I can see the screen there, here's the sun, right? And then right next to it is the Pleiades. So that's 400 light years. You can, of course, get an idea of the scale of the Milky Way, how large it is. The Orion Nebula here, 1,300 light years away. Here's the sun. And the Orion Nebula then is, I can't quite see over that far, but it was right in here. So very close again. And again, the center of the Milky Way is about 26,000 light years away. So we painted a picture here. We're sitting between the Sagittarius arm and the Perseus arm, right? So see this bounding box here? Next slide is we're gonna zoom into that bounding box. And here's that bounding box right here. And the sun, here's the sun, follow the line down. Sun is right here in the Orion spur, okay? And the Orion Nebula then is right next to us, right there. Okay, and again, we're between the Sagittarius arm and the Perseus arm in the galaxy. The Rosette Nebula is actually in another arm over here in the Perseus arm. If you're familiar with the Rosette Nebula. Okay, so that's where we're at. And here's...
Where is the Earth in relationship?
Right next to the sun. Like, yeah, like right next to the sun, yeah. Okay, so here's the Orion spur gets its name because the bright stars of Orion are prominent in that particular region of the sky. And here's Orion, taken from north of Beckworth, California last summer. This is again is a nightscape photo that I took. And here's Orion with the Orion hydrogen nebulosity, which is very prominent here. If you have a camera that's sensitive to H alpha light, then you can get stuff like this. Here's the Rosette Nebula way over here in another arm. But in our part of the world, in the Orion spur, these are all right next door. Okay. So back to our slide where we showed the sun between the Sagittarius arm and the Perseus arm. Now we're going to zoom in even more because we're trying, remember, we're trying to see how close these dust clouds are to it. And we keep zooming in. So they're very close. Okay, so see this bounding box here. The next slide, we're going to go inside that. Okay, so we're inside that little box here. We're inside the Orion arm. And let me explain what all these globs are. There's a website, Kevin Jardine has a website where he has taken the GAIA dust mapping data and actually analyzed it using isosurface analysis and has those files available on his website. You can download those files, they're called mesh files, into a software called Blender. Blender is a 3D animation software. So I took those files, downloaded them, and put them into Blender and built a project. I colored the ISO volumes here, Jardine's dust clouds, I colored them yellow. And then the blue are star densities. The higher the star density, the deeper the blue. Okay, and the red circles are hydrogen alpha emission areas. For example, here's the Orion Nebula region right in. Okay, so the sun is right here. Okay, Jardine also on his website, when you download those files, those dust clouds are labeled. Dark Horse Nebula, if you follow the line down, is right here. That's how close we are to the Dark Horse Nebula. Okay, in our galaxy, very close. That's only about 400 or 500 light years from the sun to the dark horse nebula. So it gives you an idea of where that nebula is in the sky, in the galaxy, right? It's very close. We zoomed way in, way in, way in. Now we're in that Orion spur. Here's part of that Sagittarius arm that we talked about, and the Perseus arm is below the picture. So we're zoomed in quite a bit. So there's the dark horse nebula right there. And as we follow these nebulae around the sky, those 5 clouds, we'll bring the slide up again and see where each of those clouds are. So we looked at the dark horse nebula. If you move north away from Sagittarius in the sky, you see this huge dark blob. We can see it with the naked eye. That's the Great Aquila Rift. And it's called great because it's huge. And it's in the constellations Aquila, Serpens, and Eastern Ophiuchus. Sometimes it's called the Great Serpens Aquila Rift, but we're going to shorten it. Usually called the Great Aquila Rift, from what I've seen in the literature. It's a little bit farther away, 800 light years. Pretty big at 20 by 10 degrees. And in the Lens catalog of dark nebula, it has many, many dark nebula in Lens catalog in it. And if you're a deep sky observer, then that means something. But anyway, Lens dark sky catalog, dark cloud catalog is used by a lot of people. If you have any questions, just holler them out. So that's the Great Aquila Rift, just above the dark horse nebula there. And back to Tony's photograph here from the star party, you can see the Great Aquila Rift here, just above the dark horse nebula. It's huge. And yeah.
How much confidence is there in the detail of those arms on the far side of the Sagittarius, far side of the center of the galaxy? That I find it incredible that they can see through that stuff and draw all that detail on the far side of the galaxy.
I think, well, that's a really great question. As far as I know, the GAIA spacecraft and on the ESA project has mapped the dust clouds at various distances. And so they can look at not only the stellar populations behind those clouds, but also what clouds are behind there. And I may be wrong, but that's what I gathered from the literature. And if anybody has any more information on that, just holler out.
I think by using the low enough light frequency, either radar or into the infrared, you can look through a lot of the dust clouds.
Depending on the wavelength you're searching. Yeah. Mm-hmm. Yeah, no, great question. Great question. The Great Aquila Rift here, I photographed the Great Aquila Rift from Clover Valley, north of Beckworth, last summer. These are the light dome of Reno here. But you can see how big that cloud is. And when I first started nightscape photography years ago, 5 or so years ago, I was wondering if I was processing it weird or what this thing was. But I really got interested in this huge cloud here. I hadn't been exposed to dust clouds before. Anyway, that really struck me. So the Great Aquila Rift, right there, just above the dark horse nebula. So where's the Aquila Rift? In Jardine's data that he got from the GAIA spacecraft information, he labeled this long dust cloud here as belonging to the Aquila Rift. So as you're going away from the dark horse nebula and upward towards Cygnus, this is the Aquila Rift here, also very close to us within the Orion spur. And what I thought was interesting too, in looking at the dark horse nebula and the Great Aquila Rift, is there's a little bit of a gap between those two dark clouds. Okay, and that affords us a view of certain nebulae that are in the next in the spiral arm closer to the middle of the Milky Way than in the Sagittarius arm. Here's the Lagoon Nebula in M16 and M17. They are in the Sagittarius arm. Okay. And if it wasn't for that window, we wouldn't have as good a view of those nebulae as we do. And the deep sky imagers wouldn't have as much fun because that hole allows them and us to see a nice clear view of the Sagittarius arm, at least that part of it. So if the Great Aquila Rift was just down this way a little bit, it might be hiding some of those nebulae, at least at optical wavelengths. So I just thought that was interesting that we have that little window between those two dark clouds, just how things work. And anyway, I was looking at Jardine's data and I was trying to line this up, and indeed, between the Dark Flesh Nebula and Dark Horse Nebula and the Aquila Rift, there is a bit of a gap there. It gives us a little bit of window into up here, the Sagittarius are, where Lagoon Nebula and those other nebulae are. I thought that was interesting. Now, the Gaia satellite data is what Jardine used in his graphics, but also here's a resolution view of the Gaia data that I found online. And I thought it was interesting when you look at the high resolution data, the dust clouds, using the Gaia data, is that when you get the resolution like this, you start to get all these filaments occurring and tendrils and all that kind of stuff. But in the literature, they call them filaments. Okay, so where are all these filaments coming from and what are they about? Okay, and I see filaments in my photographs too. That's always kind of struck me. The closer I look, the more filaments I see all over the place. Strands, okay, narrow strands, narrow filaments. What's going on there? If you look through the literature, a lot of it has to do, they say, with the magnetic field of the galaxy. The galaxy has a magnetic field. And here's the Planck data where they map the actual magnetic field of the galaxy. And you can see all these narrow lines here that are the field lines of the galaxy. And reading through the data, the origin of those filaments goes something like this oftentimes in these clouds, where you have star formation and an occasional supernova that creates solar winds of cosmic rays and gamma rays. The production of these rays are responsible for solar wind pressure, which causes outflow of gas and dust from the star-forming region. A lot of these clouds have star-forming regions in them. So there's outflow that's generated by these winds. So the gas and dust is then shaped by several forces, gravitational effects within the cloud, the strength of the solar winds, and the magnetic field lines of the galactic magnetic field. So depending on the interplay of these forces, you can have various forms of filaments and orientations of filaments. I thought that was interesting. Because a lot of the nightscape photography that you see online and all that kind of stuff, Milky Way, people are getting these filaments and they're resolving these interesting details of these dark nebulae. And here's the research into this, which starts to explain those filaments. I thought that was interesting.
So, question.
Yeah.
So it seems hard to imagine that you could have something that looks like a straight line, you know, out of some process where there's wind blowing. I mean, is it my understanding then that there's a gravitational force within the dust itself, and somehow these items of dust line up with sort of like iron filings in a magnet?
Right, exactly. So the pipe
So
nebula.
we're just looking at an edge. Is this an edge we're looking at, or is this actually a real line? Somebody's just it could be a plane.
Right, because we don't have the three-dimensional.
Yeah.
Right, right.
So all those forces are involved, and you think of wind, it was just blowing in all different directions. So all lined up.
One of the papers I read likened it to, in some cases, like the Pipe Nebula, a snowplow effect, where you have this bunching up of the dark dust for some reason, and there's solar winds pushing stuff up against that, and accumulates like a snowplow effect. And anyway, so if you read the literature, they talk about that, but it's the interplay, like you just said. Those different effects vary from place to place, depending on where it's at. So, interesting area of research, I think.
Pretty elementary, but what does GAIA stand for?
Good question. European Space Agency launched the GAIA spacecraft and satellite in 2014, and I honestly don't know what the GAIA acronym stands for.
Gaia was the Earth goddess.
It's probably an acronym.
Well, there
It
you
is an acronym.
Earth goddess.
Anyway, it measured billions of stars and the reddening of the stars, and they had a correlation between distance and reddening, and they were able to figure out the amount of dust between the spacecraft and the star. And so they mapped the dust in the galaxy based on those factors. Yeah. So we've looked at the dark horse nebulae, the Aquila Rift. So you're standing out there and under a dark sky, and you look up further from the great Aquila Rift, and you can see the Vulpecula Rift, which is named after the faint constellation Vulpecula, which is between Aquila, and Cygnus. So here's the Vulpecula Rift, and it's studied in its own right. Journal articles on that. They're devoted just to the Vulpecula Rift. And distance is 1,000 light years. We're moving a little bit further away within the Orion spur. Size is 9 by 9 degrees. It's fairly large. Further in distance than the Aquila Rift, like I said. And we're going to see from Jardine's data here that this cloud is somewhat separate from the Aquila Rift. And back to Tony's photograph here. Here's the Vulpecula Rift right above that huge Aquila Rift there. And you can see this with the naked eye, again, under really dark skies. And I found this on Wikipedia here. It also outlines the Vulpecula Rift as kind of a separate entity. Here's the Aquila Rift again. And moving towards Cygnus, you run into the Vulpecula Rift. Where's the Vulpecula Rift? In Jardine's data and based on the GAIA data, it's right here. So that's what he had labeled as Vulpecula. Okay, so you're moving away a little bit from the Aquila Rift. Here's the sun again. So this is about 1,000 light years or something like that to the Vulpecula. Again, we're within the Orion spur in the solar neighborhood of the galaxy.
So all the clouds you see in the rift so far, we'll just look out, naked eye.
Yes.
We're seeing entirely Orion spur.
Right, within the Orion spur. Yeah. So this is all within the Orion spur, the solar neighborhood, very close to us by galactic standards. And so, these clouds, they're close to us. They're really influencing our view of the Milky Way at night.
So what's the blue here?
Okay.
The clouds are the light colors. What's the blue?
The blue are the stellar densities, the stellar densities in that region. So denser stars. So the darker blue are the areas of denser stars. Okay. And we're not really, that we're not talking about that right now, but I thought I'd throw it in. Yeah. Yeah, there's voids there. It's interesting. When you look towards, we're going to look at the Cygnus Rift in a little bit. Cygnus has a lot of stars. It's interesting because it's bright. Okay, but when you're looking at Cygnus toward the sun, you're looking at this cloud here. A lot of stars within the Orion spur. And so it's interesting here. You can start to line up features in the night sky and say, well, I'm looking at this direction. I see a lot of stars. This has something to do as far as the Cygnus having a lot of stars in it. Okay, so mentioning the Cygnus Rift, it's above the Vulpecula Rift. And it's easy to identify because it's in Cygnus and Swan. It's between Deneb and Albirio here in Cygnus. So here's the Cygnus Rift, located in Cygnus and Swan, 18 by 8 degrees, distance 800 to 1,000 light years. It's kind of below the galactic plane, whereas some of these other dust clouds are above the galactic plane. By convention, this is above the galactic plane. This is below the galactic plane. So the Cygnus Rift is a little bit below the galactic plane, which affords us this view of this dense star field, which I just pointed out on that previous one. Okay, and here's the Cygnus Rift that I photographed last fall with the famous North American nebula here in northern Cygnus. But here's Cygnus the Swan. Here's the swan's body, and here's the wings coming out like this. Here's Deneb, right? Here's Albirio, the head of Cygnus. And right here's the Cygnus Rift. And Vulpecula Rift that we just talked about is right here. So there's the Cygnus Rift. Right? And in fact, Tony's photograph here, here's the Cygnus Rift again in Cygnus. Okay, where's the Cygnus Rift? Well, it's right here. So as you move around away from Sagittarius and the core, now we're in this next wave of what I call a wave of dust clouds here. We moved off of the Vulpecula Rift. Now we're in the Cygnus area here. And we're going to talk about these waves in a little bit more detail, but you're almost in a different wave of these dust clouds here. They seem to come in waves. And that's an area of really intense research right now from the papers I've been. okay, above the Cygnus Rift now. Our northernmost dust cloud that we're going to look at is the northern Coalsack here in the northern part of Cygnus, between Deneb and Gamma Cygni here. And here's the North American one. So the northern Coalsack is located again in northern Cygnus. It's not a huge dust cloud, 7 by 7 degrees, 700 or so light years away. Not to be confused with the southern Coalsack, which is in the southern skies, in the constellation Christ. Okay, so this is the northern Coalsack, and pretty dark. If you're under a dark sky, I mean, you can't miss it. Just below Deneb, there's a really blank spot. Kind of interesting. And here's the northern Coalsack I photographed again last fall or something. It's interesting because it sits between the North American Nebula and the Butterfly Nebula here around Gamma Cygni. And here's the Cygnus Rift that we just talked about before. Where is, yes?
Bright nebula and Coalsack, some of the same material. Bright nebula.
Yeah, these are the bright nebulae, the hydrogen, ionized hydrogen is lit up by bright stars. But apparently, I mean, I don't know which star lights up the North American. Yeah, that's a good question. So here's the Jardine labeled this as the North American Nebula. And it doesn't have, it's interesting because there is space around it that's not dust. And so maybe that relates to your question, I'm not sure. Yeah. This was an amazing project that Jardine did, taking that GAIA data and doing these ISO maps of that data and having it available online. I was just amazed anyway, yeah. So here's that slide we looked at earlier. We're kind of an oblique view looking down on the Milky Way Galaxy. Here's the sun and looking toward the center of the galaxy. Here's our Sagittarius arm. Here's the Perseus arm. They've described, researchers from Harvard have described what they call the Radcliffe wave. It's Radcliffe because it's from the Radcliffe Institute there at Harvard. But they mapped out, using the GAIA satellite data, mapped out these dust clouds in what they call the Radcliffe wave. And I want to ask them, because here's the Radcliffe wave between the sun and the Sagittarius arm, Perseus arm. In Jardine's data, you've got a wave between the sun and the Sagittarius arm, okay? This wave here. They've mapped this wave and called it the Radcliffe wave. But what about this wave right here between the sun and the Sagittarius arm? See what I'm saying? It's kind of interesting that way. So I wonder what, let me go back. So here's their article, this article they wrote, and a journal paper on it. But they only show the wave as on this side of the sun, whereas there's a whole distinct wave if you look at Jardine's data on the other side of the sun. So I'm just curious about that.
Is it actually waving?
They call it a wave because it's not exactly along the plane. In some places, it undulates in relative to the plane of the galaxy. So that's why they call it a wave, like an ocean wave doing this. See what I'm saying? You can't see that because we're not looking at the planar view totally. But if you looked at it in a planar view, it would go up and down, and that's why they call it a wave. And they think it's wavy because of a possible past interaction with another galaxy. So they've got these hypotheses. So anyway, yeah. And in summary, though, we talked about 5 major dust clouds in the Great Rift. All can be seen with the naked eye in dark skies. They're really wonderful to see in binoculars. All are on a local arm of the galaxy, the Orion spur, and all can be photographed with simple equipment. And I'll just end up with a couple of slides here of images I took. I was in Yosemite last September and took over Sentinel Rock here, the Milky Way, just above. Here's the Lagoon Nebula, just happened to be perched right on top of the rock when I was taking the exposure. So here's our Dark Horse Nebula we talked about. Right above that, here's that Great Aquila Rift right here. And lastly, I was in Old House Meadow last fall, and a meteor shot through one of my exposures. And I mean, if you take enough pictures, I guess you're bound to get a meteor once in a while. So here's our great Dark Horse Nebula. Here's our great Aquila Rift, and here's the Vulpecula Rift. And then we're cut off. So, well, the botanist in me has to say these are Yampa wildflowers. And that was kind of cool because you're out there and there's little white dots in the meadow, and they're actually wildflowers. Anyway, I hope you enjoyed the talk. That's all I have.
So all of those are the great, that you showed us, are in the great part of the Great Rift.
Yes. Yeah, and I mean, the Great Rift has no definite boundaries. It's just that I showed the northern part because we're in the north. But it extends into the southern hemisphere too. But I think it's most well known for the northern parts.
So if we're looking at this sweep of all the dark areas, go back a couple of slides there with your blue and yellow
HRD
diagram. That sweep actually, goes around this way.
Yes.
It goes, it kind of swings.
Yeah. Isn't that interesting?
Yeah.
So if you're, go ahead.
So the northern Coalsack's coming back a lot closer to the sun than the Vulpecula.
Exactly.
This is closer.
And if you keep following it around, if you're a deep sky imager, you know that there's a lot of dust in Perseus and Taurus. These are the Perseus and Taurus clouds. Because now you're moving away from the center, anti-center, right?
Yeah.
And into the winter sky. And Taurus, here's the Taurus cloud right here. It's famous for having a lot of dark nebulae. But they don't show up because you don't have that bright Milky Way behind it to silhouette. Otherwise, it would be really dramatic. See what I'm saying? So they're invisible. People don't know about them.
So what does the rift look like if you look at it in deep infrared or radar or something like that? You get away from the visible wavelengths.
Yeah.
Can you see through it, through the clouds?
Here's some GAIA data that shows the dust by brightness, categories, right, gradients. And here's the Aquila Rift, and at different distances. This stuff's available online. But you can see at only 300 parsecs here, 900 light years, there's hardly any dust. Then you move into the dust once you hit, a distance. So this is what the raw GAIA data looks like. Thought that was interesting.
And are those parts like behind Taurus not lit up because beyond that there are clouds of dust?
It's because there's very few stars.
There's
There's just not enough stars to make that contrast. Yeah. So otherwise they'd be these dramatic dust clouds, just like in the summer Milky Way. You know what I'm saying? Because they're there and they're close and they're big, but there's just nothing behind it to produce that contrast.
So some of these deep sky objects, SEA objects that turn out to be nebula, it seems to me when you're pointing out distances for some of those nebula, they're much farther away than these 5 clouds you're talking about.
Except for even farther, even much closer than the Orion Nebula.
Right. So, because I think it was 1,600?
1,300.
1,300 light years. So, to get a sense of perspective, there was one that you said was way out in the Sagittarius arm. That thing must be gigantic compared to the ones we're talking about, right? It's just it's so far away that...
Yeah, the Lagoon Nebula is in the Sagittarius arm. And
that's pretty far away relative to these clouds. Right?
Yeah, I'd have to look. Yeah, for sure. A lot further. Yeah.
So what would Galileo have done with these maps? I mean, it was incredible that we had a little tiny dot in the middle of these giant, could figure out the structure just within our own Milky Way, let alone
Just a small
like
part of
clusters.
it.
When I started taking nightscape, I was noticing these dark clouds, and I just had to ask myself, where are these things? They must be close. If they were far, there'd be stars in front of them and they blah, 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 you know, but they're so close that they block out a lot of the Milky Way that you can see optically with, you know, your eyes. So, you know.
Forget Galileo, what about
So Greg, do I need to do anything here or?
No, hang on, so global astrometric interferometer for astrophysics.
Yeah, I've been making that up, but that's GAIA.
No,
Just
no.
like coincidence.
Hey, they're keeping live for acronyms.
I'll stick with Gaia.
Yeah, Gaia's a lot easier.
So Dave, the event visibility for Dark Horse and the Aquila, are those in the summer sky,
Yes. Yes. So,
like July?
yeah, I mean, you're talking late at night in June, but July they're up, you know, after dark. And so they fade in the fall, but that's the summer Milky Way towards Sagittarius.
Right.
So you want to look south.
What was the photo length of the lens you were using?
28 millimeters for
28.
those shots.
Okay.
And I tracked it with a small tracker for about 2 minutes.
Okay.
And
Do you ever take multiple and stack them?
I do, sometimes, but for some reason I'm sort of, I lean toward the tracking. I just do. But I have. That Yosemite picture was stacked because I couldn't take all of my tracking equipment out there, you know, in the meadow. It would have been awkward. So I took a bunch and stacked them for that.
Dave, which do you think gives you a clearer image, tracking or stacking?
I think if you both do them right, they both can.
Yeah.
And I wouldn't want to say one's better than the other, but if you do them both well, I think they can both give really good results. Any other questions, comments, corrections?
Any questions from the Zoom audience? Don't hear anything.
Okay.
All right.
Thanks
So-
again.